Hello, 8th graders, and welcome to lesson 10.5. We are going to start getting into scientific notation. So we first started off the unit with talking about your exponent rules because exponent rules are going to be very important when we talk about scientific notation. It's called scientific notation just because a lot of times when we're looking at these numbers, we're using them in terms of science kind of measurements and measuring things that are either very, very small in science or things that are very, very large. So you have two different objectives here. Sorry, three. So your first one is I can identify numbers written in scientific notation. Second, I can write numbers in standard form, and I can compare numbers in scientific notation. So we're going to start by talking about what is scientific notation, how to identify if it's in scientific notation or not, as well as we're going to talk about what is standard form and being able to kind of compare our numbers when they're either in standard form or scientific notation, or sometimes they say scientific form. All right, skipping our warm up, so let's go ahead. How can you read numbers that are written in scientific notation? So a while back, I kind of introduced you to this a little bit. So a lot of times you're going to see something where it's a number value. Maybe we've got 7, okay, times then, and you're going to have 10 to some sort of power, okay, maybe 10 to the 5th. So in this case, it would look like 7 times 10 to the 5th. But really we're expressing a lot larger of a number. And so what we're going to do is I'll show you how to officially read these types of numbers as we go through. All right, so your scientific notation. A number is written in scientific notation when it is represented as the product of a factor and a power of 10. So just like I was saying, it's a product of a factor. So my factor is 7. And a power of 10. So it's always going to be some sort of number multiplied by a power of, or a base of 10 with some sort of power attached to it. The factor must be greater than or equal to 1 and less than 10. So basically what it is you're going to have a number that needs to be between 1 and 10. Okay? So I need to have that first number or that factor number to be somewhere in between 1 and 10. If it's not in between 1 and 10, then it is not written in scientific notation. Same thing goes for the base. If the base is not 10, it is not written in scientific notation. The integers can be negative or they can be positive. It doesn't matter what is in my exponent part here for determining if it's a scientific notation. The negative or the positive, though, will determine what kind of number this is, if it's a really, really small number or if it's a really, really large number. Okay, so we're going to start off by identifying if they are scientific notation or not, using basically this definition to help us understand. Oh, and then this part, we'll talk about this again as we go through, but what happens when we expand out our numbers here? So we don't usually like to leave them in scientific notation when we're trying to understand them. It's just an easier way for us to write it than to continuously write a whole bunch of zeros. So I think they had kind of explained that as well when we were watching that Brain Pop video. So what it says is writing numbers in standard form. So standard form is your usual form you write numbers in. So maybe you have like 15,000, okay? Okay, this is a standard form equation. I'm not multiplying it. I have no powers. It's just a standard formed number, okay? So when I write my scientific notation numbers in standard form, it says the absolute value of the exponent indicates how many places to move the decimal. So if your exponent is negative, think about it like a number line. Okay, so if I created a number line, you know, usually you have your 0 in the middle or somewhere, and this side's going to be your positive numbers, so like 1, 2, so on. This side's going to be your negative numbers, so -1, -2. Whenever you're looking at a number line, you always go to the left if it's negative. So the same thing works when you are changing things to standard form. If your exponent is negative, you're going to move that decimal to the left, okay? And it does depend on how many exponents there are. If your exponent is positive, you are going to then move it to the right. Just like the number line has all the positive numbers on the right, you are going to move then the decimal to the right. When we get to that part, we will talk a little bit more specifically on moving these and what you need to do. So for the first part, we're just going to go ahead and look and use this definition to decide if it is in scientific notation. From there, we'll talk about converting them to standard form. All right, so like I said, the first question asked how whether the number is in scientific notation. So here's my problem. I'm going to explain then as well. So I'm just going to explain it verbally. I'm not going to write it out, but if you want to write it out as a note to yourself, you are more than welcome to, okay? So if I go back and look at my definition of scientific notation, it says that a factor needs to be between 1 and 10. So I would look at my factor first. All right, 5.9 is between 1 and 10. And it needs to be multiplied by a base of 10 with some sort of power. Yeah, it's a base of 10 and it's a power. So yes, I would say yes to this one, okay, because of the reasons why I just determined it is. Because my integer here is between 1 and 10, and because it's being multiplied by a power of 10. All right. B then, taking a look at B, I've got my integer of 0.9. If I go back and look at my factor, it needs to be greater than or equal to 1 and less than 10. 0.9 is not greater than or equal to 1. Although it's being multiplied by a power of 10, this is going to be an answer of no, because this is not between a power of 1 and 10. Okay? Feel free to write it out or pause this video whenever you need to. I'm going to keep going though. All right, so example 2 is where we're going to start talking about changing your numbers into standard form. So when we're taking a look at that directions, they said if your exponent is negative, you're going to move it to the left. If your exponent is positive, you move it to right. So just kind of visualize in your head that number line to help you remember. If positive, you move to the right. Negative, you move to the left. All right, so what's going to happen is I'm only going to take this part of this 3.22, that integer part or that factor part, okay? And this power of 10 shows me how many times I need to move this decimal. So it is a negative 4, which means I'm moving it to the left because it's negative, okay? And I'm going to move this decimal 4 times. So here's what's going to happen. I'm just going to jump it from 4 times. 1. Okay, so I jumped it one place, but as you know, there's nothing else in front of it. So I'm just going to kind of leave them blank for right now, but I jumped 1, 2, 3, 4. So your decimal would be all the way over here. In these little pockets, then I would add in some zeros. So 1, 2, 3. So the way I would rewrite this is you can have the 0 in front of the decimal if you want, or you can just have the decimal, and then you'd have 0, 0, 0, 3, 2, 2. And this is my number now written in standard form. So the normal form you're used to seeing your numbers in, where nothing is being multiplied or there's no exponents with it. Okay. All right, part B then, write 7.9 times 10 to the 5th in standard form. This time I have a positive exponent, so I'm going to move it to the right. I'm just going to start with the factor that I have, so 7.9. And what I'm going to do is I'm going to just take that decimal and move it 5 places. So again, I'm going to run out of space where there's no numbers, and that's okay. We're going to fill them in with zeros. So 1 spot, 2 spots, 3, 4, 5. So now every time there's this little jump here, I'm going to add in some zeros. 2, 3, 4. Now, since this is a larger number, remember then your decimal would be at the end here. Anytime your decimal's at the end, you don't necessarily need to re-add it into your problem. So to write this in standard form, it looks to be that I would have 790,000. Okay. Decimals at the end, when it's at the end on the right side, you do not need it unless there's any actual numbers at the back side of it. When it's in the front, though, it's showing me a large, very small number, and I need to make sure I have that decimal. All right. We're going to go on to the on your own here. So I want you to go ahead and take the time to answer these questions here on your own. Try out your best. So pause the video, take a minute to go back through your notes if you need to, or rewind this video to go back and see if you are doing these correctly. I'll give you a few minutes to do that. While you are about to do that, though, I'm going to give you your code word. Your code word is Pythagoras. So like we learned earlier about Pythagorean theorem, I want Pythagoras though, okay? So go ahead, take a minute to pause this video, work out these problems. When you get back, I will have the solutions up here. Alrighty, welcome back. Here are your answers for these problems. So number 1 is a no. Didn't write out my explanation, but the explanation would be that your 12 is not a number between 1 and 10. So this is a no, not written in scientific notation. Sorry. Problem number 2 then. It's just the integer of 6. So there's no decimal place, but you can always assume that it's on the right side of this. So all I did then was move my decimal over. I'm not sure why that did that. Ooh, sorry guys. Move your decimal over 7 places. So basically in this case, you're adding 7 zeros to it. So you get 60 million. Okay. Continuing on then with number 3, we are moving our decimal to the left. Okay. I move it to the left 5 places. So I should get an answer 0.000099. Okay, that would end up being what okay, tenths, hundreds, thousands, 10,000s, hundreds, thousands, 99th millions. It's kind of hard to say. So that's why it's a little easier to write in scientific notation. And then this one says it has a positive exponent. We're going to move it 4 places to the right, so swooping it over. Basically, what ends up happening then is I add an extra 0 at the end, and this becomes 12,850. Okay? Feel free to leave comments below if you've got questions, or email me. I'm going to be a little quicker on email or texting if you would like to do that. Make sure you also have the code word going through. Okay? Let's keep moving forward. I think though, just because of the timing of this, is that we are going to cut this video off. So please make sure to catch me on part 2 of this lesson. So then part 2, we'll talk about example 3 and 4. And then we will continue on with what your homework is. So I will see you in part 2. Keep making sure that you are looking out for that code word, all right? See you then.